Hello everyone, my name is Mustafa and today my group and I will start with our presentation for the unit Global Logistics and Supply Chain. We will talk about managing inventory in the supply chain which is related to our case study. My group members are Tafara, Maharan and me, Mustafa. Our presentation is divided into two parts. The first part covers the relative theories of the chapter, which is chapter 9, Managing Inventory in the Supply Chain, and the second part is the introduction of the case study and the answers of the question related to the case study. The important theory in this chapter is EOQ, Economic Order Quantity. So, what is economic order quantity? Economic order quantity is the ideal order quantity a company should purchase to minimize inventory costs such as holding, storage, and order costs. This production scheduling model was developed in 1913 by Ford W. Harris and has been refined over time. The formula assumes that demand, ordering, and holding costs all remains constant. Here, there are two basic forms of economic order quantity model. The first is fixed order quantity and the second is fixed order interval. In this slide is the formula to calculate economic order quantity. Here we can see a diagram which represents the EOQ model. The diagram shows how the stock behaves. For instance, a company starts selling from 4,000 stock, and as the stock sells out till it reaches 2,000 stock. Here we can see the dotted line. It is the safety stock. So what basically company do is, for example, is that when their stock gets to 1500 remaining out of the 4000 stock, they got to place another order. That's because of the lead time that it takes for the order to be delivered. This is what companies do on lead time. Companies know that it takes some duration for the goods to be delivered, so when the stock sells out and comes to 1500 at the safety stock, the company will place another order so that by the time the stock gets to zero, the stock will arrive, and this obviously is if there are no uncertainties and if all works perfectly fine. This diagram shows basic assumption of the simple EOQ model. This diagram shows the economic order quantity. Here, the total cost per unit is minimized by the carrying cost and other cost is equal. Here, the dotted line is where we can place another order. When we apply the formula, we are able to calculate the economic order quantity. These are basic assumptions in building this kind of model. Another example of how companies keep safety stock. On the previous example, we look under the assumption that everything is fine and that there are no uncertainties. So if there are uncertainties, this is how companies behave. When the order sells out, and here is the reorder point and below is the safety stock. Every company is not same, but the idea is that they get to a particular point and think that they have to reorder again because it takes time for the goods to arrive. The second part of the presentation will be done by Maharul. Thank you everyone.
Hello, I'm Mahra. This case study is about baseball card Emperor BBE of Lewiston, Pennsylvania. The company distributes baseball cards to sports card retailers. The Vice President Kenny Craig of Logistics of BBE asked the staff to evaluate the air carrier service to ship the cards to analyze if it's better than the current transportation system of motor carrier. To choose the best option to deliver the cards, the report needs to suggest whether air carrier is better or not. Let's start with the calculation of EOQ. As it is shown, the figure report by Sir Nick Ginger, the annual demand is 6,000 cases of cards. Cost per order is $75. Cost of one unit of inventory is $96, and inventory carrying cost is 30%. Applying this number into the EOQ formula, we have found the economic order of quantity for BVE is to be 177 units. For the rest of the calculation, I'll pass on to my fellow teammate Tafara. Thank you.
Hello, my name is Tafam Shaninga and I'll be presenting the calculations for this part of our presentation. I believe my colleague has clearly presented concepts, theories, and functions of economic order quantity and the formula for economic order quantity and its purposes. So, to find total cost without transportation included, we say our annual cost of ordering together with the annual holding cost. So our economic ordering quantity, our number of units we get from that is 177, and we plug it in both parts. So under annual ordering cost is basically your annual demand over the EOQ units that we got together with the cost of replenishing inventory. That gave us 2,542.37. And then on the other side, we have the annual holding cost. Annual holding cost contains the EOQ units divided by 2, since it's annually, together with the $96 that comes from the cost of one unit of inventory multiplied together with the inventory carrying costs, which gave us $2,548.80, which in total gives us $5,091.17. This is before or excluding transportation. And then when we talk about transportation, we start off with the motor carrying costs. So we started off by listing all the data that we have. For motor transportation costs, it's simply the total inventory cost plus transportation cost. Things to note in this side are the transit time, which is 4 days, the cycle time, which is 7 days, the motor carrying carrier rate, which is $1.20. Weight in both scenarios is going to be the same, which is 50 pounds. So we then say our TAC is equals to our annual cost for specific order and cost of inventory in transit. So these two together are already the total cost of inventory. Then the transportation cost is just simply the number of units. You have the unit weight and the motor carrier weight rate, which is $1.20. So what happens when we plug it all in together? So you see the first two parts, the first part, which was our annual cost for specific order quantity, when we calculated with the figures given, we got 5,097.36. Then when we include our in-transit time and our cycle time, 4/7 together to get the cost of inventory when it's in transit, it gives us 1,747.75. And then the cost of transportation itself, this is now including the motor carrier rate for $1.20, gives us 3,600, which in total is $10,438.92. For air transportation carrier costs, it's the same, except our transit time is now 1 day, our cycle time is 2 days, and our air carrier rate is $2.50, but everything else is the same. So first half, obviously, of our annual cost for specific order quantity, when we plug in our figures, we get $5,091.71. Then where we talk about our cost of inventory in transit, this is the 1 day in transit over the 2 day cycle time when we multiply together with the figures given, we get $1,529.28. Then our cost of transportation, where we now include our air carrier rates of $2.50, gives us 7,500. In total was 1,000. Total, sorry, was $14,120 $45. I think in summary, the motor transportation is far cheaper than the air transportation. I will now pass on to my next colleague.
Hello again. So on the decision of which alternative is BB is supposed to use, as we have seen in the calculation, the total cost for motor transportation is less than air transportation. Therefore, sticking to motor air transportation is the best option to distribute the cards. To conclude this report, the EOQ economic order of quantity has been explained, followed by calculations of EOQ. The total cost of motor carrier transportation and air carrier transportation has been calculated. From the calculation, as the annual cost of air carrier transportation is higher than motor carrier transportation, it is suggested that to BBE to stick to motor carrier transportation. That's all for our report. Have a great day. Thank you.